In this question, we have the inner loop, okay, possessing a current. So inner loop will create magnetic field. So if you use your right hand grip rule, you can know that within the loop, magnetic field is pointing into the page. So let me draw plenty of crosses, okay. Maybe I have drawn around 15, okay. So outside of the loop, right, outside of this inner loop, this magnetic field, right, will be pointing out of the page. However, right, you got to realize that this magnetic field will get further and further away, okay. If inside of the inner loop, right, you expect, let's say, 15 crosses, the grand total of all the lines, right, outside of the loop will be 15 as well, okay, because all magnetic field line must close up into loops. So how many crosses, it must be matched by how many dots outside. But overall, right, for the outer loop, okay, it is capturing more crosses than dots. So the net of the crosses and dots, right, that it captures, right, is flux linkage, okay. So it's the cross plus the dots, right, equals to the flux linkage. Yeah, and this flux linkage, right, obviously will change depending on the current in the inner loop. And by Faraday's law, EMF is equals to d phi dt. This flux linkage changes according to the current, okay, which gives rise to the magnetic field. So essentially, right, you are going to take the gradient of this graph, which is a constant value here. So that will tell us it must be a constant. Then, right, as this current decreases, net, right, will be the outer loop, right, will have a net flux linkage which is into the page, but it is decreasing. Therefore, to produce, right, a magnetic field to oppose a change, the magnetic field lines that this induced current will produce, right, will be into the page, because the lines, the net flux, right, will be into the page, and you want to oppose the decrease, so you will produce lines into the page. And by your right hand grip rule, okay, the induced current will try to flow in a clockwise manner. So answer is A.